Concentration of ores. In this module, you will learn about the different methods used for the concentration of ores, which means removal of unwanted materials associated with the ores. Minerals from which metals can be extracted conveniently and economically are called ores. Ores are found in the earth crust and contain one or more metal compounds along with certain non-metallic and earthy impurities. The extraction of a metal from its ore involves several physical and chemical processes such as the concentration of ore, isolation of metal from the concentrated ore, and purification of the metal. All these processes are collectively referred to as metallurgy. In this module, you will learn in detail about the first step of metallurgy, the concentration of ore. Concentrating an ore means getting rid of all the unwanted materials from the ore, which are also referred to as the gangue. Depending on the properties of the ore and its gangue, the methods used for concentrating an ore may include hydraulic washing, magnetic separation, froth flotation, and leaching. Let's first learn in detail about the method of hydraulic washing, which is based on the difference in the gravities of the ore and the gangue particles. In hydraulic washing, powdered ore is spread on a sloping block having grooves. When a stream of water is allowed to flow over the ore, lighter gangue particles get washed away, leaving the heavier ore particles behind within the grooves. In magnetic separation, powdered ore is passed over a conveyor belt running over two rollers, one out of which is magnetic. The magnetic particles get attracted to the magnetic roller and travel a distance with the conveyor belt little longer than the non-magnetic particles. Therefore, the non-magnetic particles drop down first, forming a heap, whereas the magnetic particles drop down a little later, forming a separate heap. The next method used for concentration of ore is the froth flotation method, which is based on the difference in the wetting properties of the ore and the gangue particles. The froth flotation method is used exclusively for sulfide ores, where the ore particles are wetted by oil, while the gangue particles are wetted by the water. In the froth flotation method, the powdered ore is mixed with water and small amount of pine oil. The resulting mixture is then agitated by blowing compressed air through it. The oil in the mixture forms froth with the air. The froth rises up to the surface containing the ore particles. The gangue particles, on the other hand, settle down in water. Froth is then collected in another container where it is washed and dried to obtain the concentrated ore. In the leaching method, the powdered bauxite ore is treated with hot and concentrated solution of sodium hydroxide. The ore dissolves in sodium hydroxide to form sodium aluminate, and silica dissolves to form sodium silicate. The other impurities, however, remain undissolved and are later filtered out. The filtrate containing the sodium aluminate and sodium silicate is further treated with carbon dioxide gas. This leads to the precipitation of the hydrated aluminium oxide, leaving behind sodium silicate in the solution. The hydrated aluminium oxide is then filtered out and heated strongly to form pure aluminium oxide. In this module, you have learned that naturally occurring chemical substances containing metals are called minerals, and those minerals from which metals can be extracted conveniently and economically are called ores. The extraction of a metal from its ore involves several physical and chemical processes, namely concentration of ore, isolation of metal from the concentrated ore, and the purification of the metal. Concentration of ore means getting rid of all the unwanted materials, which are also referred as gangue from the ore. Commonly used methods for the concentration of ores include hydraulic washing, magnetic separation, froth flotation, and leaching. Hydraulic washing is based upon the difference in the gravities of the ore and gangue particles. Magnetic separation is based on the difference in the magnetic properties of ore and gangue particles. Froth flotation process is based on the difference in the wetting properties of the ore and gangue particles. Leaching process is used when the ore particles are soluble in such a solvent in which the gangue particles cannot dissolve.
Aluminium is the third most abundant element in the Earth's crust, but it's not an easy metal to extract. It's found as a metal ore, meaning it's combined with other elements. And aluminium's high reactivity means the compounds it forms are very stable and difficult to separate. Bauxite is a natural ore of aluminium. The rocks get their colour from red iron-3 oxide impurities in the ore. Before aluminium can be obtained, these need to be removed to leave pure aluminium oxide, known as alumina. The Bayer process removes the alumina by a series of chemical reactions. After filtration, a mixture of pure aluminium oxide and water remains. The mixture is heated to 1200 degrees Celsius, causing all of the water to evaporate, leaving a dry white powder, alumina. Another process is needed to extract the pure aluminium. Electricity can be passed through a chemical compound to extract different elements. When a current is passed through heated lead bromide, molten shiny lead metal and brown bromine gas are produced. This same process, electrolysis, can be used to separate the aluminium and oxygen within alumina, though this requires a lot more heat and electricity. The compound is placed in electrolytic cells, which raise the temperature to about 1000 degrees Celsius. These use enough electricity to power a small town. This melts the aluminium oxide, freeing the positively charged aluminium ions and negatively charged oxide ions. As a current is passed through the electrolytic cell, the positive aluminium ions are attracted to the negative carbon cathode, where they gain electrons to form aluminium atoms. The negative oxide ions are attracted to the positive carbon anode, where they lose electrons to form oxygen gas. Before bonding with the carbon of the anode to produce carbon dioxide gas. When final impurities are removed, pure aluminium is left. This process is used to extract millions of tons of aluminium each year.